Hello everyone. In this video, I will be discussing on the interrupts in 8085 microprocessor. What are the different interrupts and how the interrupts are executed, and what happens when an interrupt has been executed, and how well you can um, what would the sequence of execution of instructions in your 8085. So this video would be helping you getting a knowledge on the interrupts of your 8085 and how interrupts can be used over there. First of all, what actually an interrupt means? What is the definition of an interrupt? So here, interrupt can be any process either from an external device or from the internal device. Interrupt, or we can say interruption to the main program. So what happens when an interrupt is been, what actually an interrupt is that? So it is like a mainline program is been continuing. Suddenly an interrupt is been called. It will jump to the interrupt. It will execute the interrupt, come back to the main program and execute. This is the process what occurs in an interrupt. Okay, this is actually a process which occurs over here. So right now I'm speaking out. Suddenly an disturbance has been came up. So what I will do? I will go for responding to that one. So this disturbance, whatever the disturbance created at the outside, okay. So this disturbance is nothing but the interrupt. Disturbance or whatever it is there, that is nothing but the interrupt. So coming to the interrupt types, there are two types of interrupts. First one is maskable interrupt and non-maskable interrupt. So now I told you, first of all, a disturbance is nothing but an interrupt. So when a disturbance has been created, whether I am responding to the disturbance or I am avoiding the disturbance and going on speaking out the lecture is nothing but maskable or unmaskable. When I'm continuously speaking out without having a delayed or without concentrating on the disturbance, then it is non-maskable. Okay, that is without which is said to be a maskable. So disturbance is an in the delay, or what is an interrupt, and the disturbance when it is being created, I'm avoiding that one and going on speaking up to the lecture. So that is called as maskable interrupt. And non-maskable is that. So immediately a disturbance has been created such a way that I need to rush it out without any delay. Then it is called as non-maskable. There is no delay. It cannot be delayed. Cannot be delayed. So see here, this is cannot be delayed. So interrupts are classified into two types, vectored and non-vectored. Again, there is the same maskable interrupts or same non-maskable interrupts are being again classified into vectored or non-vectored. What is a vectored? What is a non-vectored? So if a vectored is there, when you say the interrupt provided the address itself of the subroutine. I told you. So when you go for an interrupt, what is an interrupt? The mainline program has been getting. This is the main program. So main program is calling a subprogram. Subprogram is nothing but the interrupt. This is an interrupt call, let's say. So it could execute the interrupt. So this is an interrupt call. Once it completes the interrupt, it comes back to the main program and execute the remaining part of the program. So here, what is a vector? So when an interrupt is being called or when an interrupt is been there, it has the address of where this program is been there, that is called as a vector. And if at all the program doesn't have the address where the program is been there, it is called as non-vectored, and it is externally provided. It is called as non-vector. So interrupt subroutine. Interrupt is nothing but interrupt subroutine. So responding to the interrupt and what are the now here, what are the interrupts in your 8085 microprocessor? Now we will be concentrating on our 8085 microprocessor. What are the interrupts in 8085 microprocessor? So here the interrupt in the 8085 microprocessor is controlled by two instructions, EI EI stands for enable interrupts. And next one is DI, disable interrupts. And out of all the interrupts in your 8085, there is only one non-maskable interrupt. What is that? Only one non-maskable interrupt. That is nothing but the trap interrupt. Only one non-maskable interrupt. Remaining all are maskable interrupt. So here you are having two instructions. EI. EI stands for enable. DI stands for disable interrupt. These two interrupts are used, instructions are used to enable or disable or have a control over the instructions. So these are the interrupts which are being listed out over here are 8 interrupt inputs. The first one is INTR. The first one is INTR input, which is there. And externally, you will be having RST6 5.5, RST 6.5, RST 7.5. And the fifth one is trap. These are the 5 interrupts. So once again we are listing out. The first interrupt is INTR. Second one is what? RST. What is that? 5.5. Next one is what? RST 6.5. RST 7.5. And last one is what? Trap. These are the interrupts. And these interrupts are given a priorities. These interrupts are given some are maskable, some are non-maskable, some are vectored, some are non-vectored. Out of all this one, all are what? Maskable interrupts. Only one. This one is non-maskable. Okay. And then out of this one, INTR is non-vectored. Okay. It is non-vectored. It is non-vectored. It is externally, it will be provided the subroutine. Remaining all are what? Vectored interrupts. These all are interrupt itself will provide you the vectored interrupt. So here, tabular column is been given over here. You can see this is maskable, this is maskable, maskable, maskable. Only trap is non-maskable. All these are what? Vectored interrupts. Only this one is non-vectored. So interrupt vector. What is an interrupt vector we will have? Interrupt vector is nothing but a table. We say it as interrupt vector table. Over here you can see this is the table IVT, interrupt vector table. So interrupt vector table is a memory location which is having a memory page which has the address from what? 00 to 000 H to 00 FFH. So this is the memory location located in the memory where totally it has one specific routine address would be given. The purpose of the intervector table is to hold the vectors that redirect the microprocessor to the right place where the interrupt arrives, where the interrupt subroutine has been there. So intervector table are which will be giving over there. So next one is how this one is there. So when you are referring to RST, so here you can see RST 0 interrupt. It is referring to call, it is equivalent to what? Call 000. So RST 1 is what? It is equivalent to call 0010. So like that way, this is about the specific addresses where the interrupt subroutine is been written. So it will send the execution directly over there. So by this way, what happens over here when an interrupt is been there, automatically a stack would also will come into existence with the interrupt. So what the stack would be coming over here and how it processes over here, we'll see this one. So first of all, when an interrupt is been called, what happens when an interrupt is been called? So immediately the memory address of the next instruction, whatever the next instruction which is going to be executed. Suppose this is like interrupt call. So the next address is been taken and moved into what? Stack. It is placed in what? Stack. Similarly, when an interrupt subroutine is been completed, so what happens is that the stack stored address is been brought up and it has been executed in the main program. This is about how it will take place in this one. And next one, out of all the interrupts, we are having total 5 interrupts. Out of 5 interrupts, the priority is given to each of these interrupts. Like INTR interrupt has the least priority. Trap has the highest priority. Priority sequence would be top priority is what? Trap. Then RST 7.5, RST 6.5, RST 5.5. Then last comes is what? INTR, least priority. So when you go for out of this one, if you want to, doesn't want, if at all, at the time 2 interrupts have been provided, it will see which is having the highest priority. According to the highest priority, that interrupt would be executed. But I want not that interrupt to be executed. Then I can go for set interrupt mask instruction. SIM, set interrupt masking. And there is one more, it is there, reset interrupt masking. So here the bit pattern of this one number associated to the SIM instruction will give you what are the interrupts to be enabled, what are the interrupts to be set or available. So here one is called as masking, set an interrupt mask. So when it is masked, one it has been there, it is the interrupt is been hidden or the masked. If it is 0 is there, it is not masked. So here you can see the bits pattern is been given over here 0, 1, 2. This relates to RST 5.5, RST 6.5, RST 7.5. If it is 1, it is masked. If it is 0, it is available. Okay. Now coming to this one. Again, this one is what? RST 7.5. Force RST 7.5 to reset. Okay. And out of this, all these bits, this fifth is not used. It is done simple. And these 2 bits are used for serial communication. So this is the how you set or reset a mask. And remember over here, out of all these interrupts, INTR is a non-vectored. It is an outside itself. It will provide the memory. And next one is that out of this one, trap cannot be masked at any time. You won't mask an interrupt. So interrupt masking and all those things is there. They are not much required in depth of this one. And reset. Suppose if you have made up the mood that I want to make that interrupt available, then you can make it resetting it RIM and providing this instruction and using of this instruction you can reset the interrupt max. So whenever reset is nothing but making it 0. So this is the bit pattern of an reset. So it indicates whether the interrupt is been pending or whether the interrupt is being executed. And this out of all this one, the 7th pin over here is also used for what? Serial in data. So this is about the total interrupt concepts of 8085 microprocessor. Hope you have understood this one, and thank you for watching this video. You can see the next video on subroutines. Thank you.